You can share your screen and start the session. Or before that, introduce yourself to audience.
Yeah, myself, I'm sharing the screen. For that. So myself, Venkatashna. So I have total 9.5 years of IT experience in middleware. I worked on SOA, OSB, and WebLogic, and since the 6 years I'm working as a Mule developer as well as support, and working in Zensar since two years. Earlier I worked on IBM, uh, and I was a certified developer. Uh, so I working on multiple domains. Uh, so today our topic is SSL certificate creation and upload the process in MuleSoft. So before going to that SSL certificate, so why we need to use the SSL certificate, and why should we require the upload process in the MuleSoft? So so that first we go through with that process. So then uh, we can we can see the how we can convert using OpenSSL and PowerShell scripts. So we can convert and we can concatenate the multiple certificates into the single certificate. So so that is a one another. So we need to go to in this session. Uh,
Benefit, we have some background noise, like participants are telling.
just now it's okay.
Now it's
Hello.
better, Venkata. Now it's better.
Okay. Okay.
Yeah. Can you please maximize this screen down we have, right? Presenter mode. Or otherwise, just click that maximize, so it will maximize the screen. We have one to third, fourth option.
Now is it okay now?
Is this okay? But you can maximize. It will be better. Like in down we have, right? Like yeah, right. Yeah. Next one.
This one
Yes, yes,
slide
that
show.
one. Yes, yes,
This one I
yes,
have
yes. Right.
clicked.
Yeah. Thank you.
Uh, so today agenda understanding the SSL certificate the functions. So how we are need to stop. Um, so we need to see the SSL functions and data transfer over SSL certificate formats. How many types of certificate formats we can able to uh, use it in our MuleSoft. But as part of this session, we are working on PFX certificate to PEM certificate. So that conversion we can work with the OpenSSL and uh, PowerShell scripts, and then after to upload the load balancer certificate. And so demo I cannot able to show as of now because as per security reasons. So I just show you the screenshots and where we can upload the certificates so that I can show you as of now. And then coming to session, can start the SSL certificate introduction. So why do we use the SSL certificate? So what is the main purpose of certificate we are using? in any of web access or any of the server. So to prevent to prevent the hackers, first main reason, and to secure our service, so no one needs to take our data, or uh, so that will be in the different format, like algorithms we have, uh, and encryption formats we have. So um normally we know that every web service have the https protocol to secure the certificate communication between the two systems. So more and more websites getting the secured, so using the https contains the ssl or tsl technology to secure the information between the two systems. So the encryption, why we need to do the encryption? So directly we can use the http protocol, and we can use our web server. So that will affect on our web server, so anyone can see our service, and they can uh, store our data. So in that way, this ssl certificate uh, introduced uh, over the web, and the in the technologies, in all technologies. So the the main advantages are securing the communication and data integrity. So as I said, like http makes a secure connection, establishing the encrypted link between the browser and server, and or any two systems. So this is the first advantage. And data integrity, https provide the data integrity, like uh, we can encrypting the data, the uh, to prevent the hackers. So that is the main advantage. And uh, and the third advantage is privacy and security, uh, and the faster performance and the future perspective. We have been introduced this ssl, uh, the privacy and security, so which makes like to protect the websites from preventing the hackers passively listen the communication between the browser and the server. So we are mostly prevent from the hackers, and the faster performance. So by using this https, so uh, unauthorized users not able to access. So like we can encrypt the data transfer between the systems, and the future perspective. So it is the most safe in the internet, the user and websites owners. So if you see this communication between the http and web server, so the http and web server username and password, it's directly communicate with the web server, and it can respond to the browser. But in https, it's encrypting the data, so but no one can listen, and no one cannot able to see the data of the web server. So then it is a protectable format. We are connecting to the web server. There are multiple functions we have, like asymmetric cryptography and symmetric cryptography. Coming to the asymmetric cryptography, so you mean to say like everyone knows the cryptography format, like it's contains a mathematically related key pairs, encrypt and decrypt the data. Okay, so in the key pairs, one key shared with anyone who interested to communication, this is called public key. And the other key pair is kept, the secret key is called the private key. So sometimes someone needs to connect us, they are very interested, like like they are sending a data to our system, uh, because the communication should be happen, like between the two systems. So in the our architecture perspective, so in that case, so we need to provide the public key to them, and we are keeping the private key in ourselves. And whenever they'll send the data to our system, so based on that public key, so we will by using our private key, so we'll encrypt it, and then we can allow the connection. So in that way, between the two systems, so the communication will be happen. And public and private keys are mathematically related, and were created using the cryptographic algorithms, which are based the mathematical problems termed one-way communications. And these keys are used to encrypt and decrypt the data. So as I said, like public and private key encrypt and decrypt the data in the asymmetric cryptography. So no one can able to find out so how it is uh, uh, decrypting and how it is encrypting. So that's why this asymmetric cryptography will work. Um, the sender encrypt the data and with the receiver public key and send it to the receiver. The receiver decrypt using the related private key. So as I said, like uh, private key contains ourself, and public key someone needs to connect to our system. So that is the entire of this para. Like SSL uses the asymmetric cryptography initiate the communication, which knows the SSL handshake. So you know that we are mostly observing on MuleSoft the handshake problems in between the two systems. Like uh, there are timeouts also will happen by using the SSL handshake, or else uh, the the security key expires. So there are many ways, but the handshake needs to be happen public and private key between the two systems. So then only the handshake will be happen. In asymmetric cryptography, the sender encrypt the data and receiver's public key send it to the receiver. The receiver decrypt using the related private key. Most commonly, asymmetric encryption used EL, GAML, and RSA, DSA, elliptic curve techniques, and PKCs. These are all asymmetric cryptography algorithms. Uh, so as of now, uh, asymmetric cryptography, now we are going to work on like asymmetric cryptography uh, and combining with the symmetric cryptographies. So all these combinations we are creating the SSL certificate now. So that is the main agenda here. So this is the asymmetric cryptography format. Like if someone sender sent to the request uh, by using the key pairs. So the receiver can decrypt the using private key. So and it can respond again with the public key. So this is the way the communication will be happen. And coming to the symmetric cryptography, so this is quite uh, 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 one-to-one communication. We can see like it's very understandable format, but asymmetric cryptography is some bit difficult to understand and to establish the connection. So there are multiple ways and multiple algorithms we have in asymmetric cryptography. Most of the cases asymmetric cryptographic uh, certificates we can use it in our MuleSoft, not only MuleSoft, in all our technologies. So because that is it's a combination of many things like public key, private key, and the combining with the public and private keys. So it's a combination thing. And symmetric cryptography is like one key encrypts and decrypts the data. Both the sender and receiver should have this key. So it is a only one key mechanism. So the key will send to the receiver, and we can decrypt and we can encrypt. So uh, it's it's like one-to-one mapping, one-to-one connection, one-to-one key pairs. So we don't need to bother about multiple key pairs here. Um, this SSL, there are many algorithms like AES 128, AES 192, AES 256. So these are all the uh, functions in SSL. And how data transfer will happen by using an SSL, uh, by using the asymmetric and symmetric uh, cryptography transformation. Like SSL protocol uses asymmetric and symmetric cryptography to transfer the data securely. So this already we are discussing all these points by using an SSL. So it's the same thing we are following in SSL. SSL communication between the browser and the web server is mainly divided into two steps: the SSL handshake and the actual data transfer. So before we are transferring any data, so we should happen the handshake between the two systems. So then only we can able to transfer. So until unless we don't have any handshake between the two servers, so the uh, the data can't able to transfer, and it can give the more errors. So the handshake issues. So that's why that is the major part. So uh, when we are creating this SSL certificate, yes, SSL certificate formats, like there are many formats we have. So but we uh, as per this demo, so whatever we are doing uh, in the demo, so that transform that certificate formats, we gathered most of certificate formats, like 509 certificate format. This is a standard defined structure certificate format, and uh, it defines the data fields should included in SSL certificate. X509 uses the formal language abstract syntax notation. So this is entirely like the structure of the X509, and there are different format like 509 certificate such as PEM, DER, PKS, #7 and PKCS, #12, and base 64 ASCII encoding format. So all these are certificate formats. Now we are working on like PEM, PKCS #7 and PKCS #12 and PEM format. So uh, when using a key store tool, so there we don't have you can see when you are converting any certificate, you can see these formats. But when using a open SSL and uh, PowerShell scripts or any Linux commands, so you can't able to see in directly this certificate format. There is a standard structure. We need to convert the certificate into the PKCS and PEM format, and then we can convert into the keys. I'll show you the how we can able to convert the certificate. Yes, this is a standard structure for X509 data structure, like by using base 64 ASCII format. Uh, like PEM contains .pem, and it can includes like .crt, .cr, .key, uh, and PKCS #7. Now .p7b and .p7c. So these are all the data structures. So it's internally used in the X509 certificate. So the mainly our focus on PEM PKCS #7 certificate format. So now uh, where we will get this certificate, how we can able to do it uh, in our MuleSoft environment. So how we can convert it. So basically this certificate will get PFX formats. So I'll tell you later that. And this PM format, like it's a base 64 ASCII encoded files, and the certificate types .pem, .crt, .cr, and So once you converted into the PEM, so you can able to convert .crt, .cr, .key. This PEM includes the server certificates and intermediate certificates and the private key and single file. So when you're converting this PEM, so it contains like server certificate and intermediate certificate. We need to convert the multiple certificate and combine it. So that is our main agenda on this certificate conversation. Uh, I need to upload that certificate in our MuleSoft environment. And the certificate and the server certificate and intermediate certificate also the separate CRTs or C.cr files. So once you convert the certificate, so it contains either CRT or C.cr file. Uh, the private key we can convert. It's a only one key we can able to convert. uh, that will not change. So once we got a .pfx file, so that will convert into the .pem and .crt or .cer and .key. So these are four formats we need to convert. So each PEM contains like it can start with the begin certificate and end certificate statement, and the private key also like begin RSA private key and end RSA private key, and CSR begin certificate end certificate. These are the basic once we convert the certificate, and then we need to save it in like from begin certificate uh, before we have some uh, extracted codes, so that we can delete and we can use from begin certificate. So that conversion we can see that this is a PKCS format. This is a cryptographic message syntax standard. uh, this is also same as like .pm format, like so it can also having the base 64 ASCII encoding file extension, and it have the .p7b and .p7c stored format. uh, and it's also like starts with the begin PKCS 7 and end with the PKCS 7. um, and the another format DER format. So DER format also it's a binary form contained the uh, in .ter and .cer files, and these certificates are mainly used in Java based web servers. um, like if you have the end system or when they are connecting from source Java web servers, so we are using this DER formats, uh, like PKCS hash 12 format. This certificate is a binary form contained the .pfx or .p12 files, and this is the main thing. Like you need to create the intermediate certificate private key, as I told you. Like so, from the pfx file, we can convert into this all these format. The certifications are mainly used in the Windows platform. So, any questions till now, or else can we go ahead with the demo how we can do that conversion?
As of now, no questions. Nikata, you can go ahead.
Okay. Okay, so the prerequisites of conversion of this certificate. So we require the SSL, Open SSL. This is a freeware tool, and PowerShell. This is also freeware. It's inbuilt in our Windows. Uh, in company standards, they cannot allow Open SSL if it is in a free tool as well. But in our local system, we can able to do that, or else some companies can able to provide this OpenSSL as a free tool. Uh, so it depends on the company policies. So but it's required the admin rights. OpenSSL required the admin rights, because when you are converting any certificate, if you have the admin rights, so that would be better to change the certificate in exact format. So in that way, any of free tool or anything, so you should have the admin rights. So that is the main thing when you're converting the certificate, because sometimes the conversion when you're doing without the admin rights, the encryption will not happen properly. Encryption will be happen without the admin rights as well, but there are some algorithms will not add it without the admin rights. So better you can use like admin rights in your open SSL or anything. Okay. Okay. Before converting this certificate, so we can go ahead with this PK, PFX, and PKCS hash 12 certificates to PM format. And there are, as everyone knows, like load balancer we have in the MuleSoft. There are two types of load balancer, like shared load balancer and dedicated load balancer, and which will distribute the traffic among the cloud workers. Uh, so, uh, especially this can work with the cloud, but I didn't try it with that hybrid and uh, the on-prem. Like, so we are working on cloud systems, right? So when we are working on cloud systems, so we identified all these things, converting the certificates. So basically, this is for the cloud systems, uh, cloud environment. So each application deployed to the cloud will have the shared load balancer, that is a multi-tenant, and shared load balancer provide the functionalities like TCP load balancing. But at the same time, it is have the lower rate limits, but it doesn't allow the custom SSL certificates configuration, custom DNS. As I said, like uh, in the shared load balancer and the dedicated load balancer, that is the main difference. The shared load balancer, uh, it can balancing the limits and does not allow the certificates, custom certificates. To overcome these limitations of shared load balancer, we have to use the dedicated load balancer. That will be we can use the customized certificates and the DNS we can able to add in our environment. That is the main. And yes, uh, so so basically, when converting these certificates, so if you ask any questions like, so where I can get this PFX file, and the how can I identify is a PFX file or not? So who will give this PFX files? So basically, this PFX file have some tool uh, uh, to generate PFX and to in the server side. So infra team or the server managing team have that access. As a developer, even until even architect also don't have access for that server. So they can upgrade and they can create the CSRs first. Then after they can create the PFX files. So when they are creating the CSR and PFX files, so they have the they can able to generate the intermediate files as well, but they will not share with the intermediate files with us. So they can only share the PFX files. So based on this PFX file, so we need to convert into our standard format, like uh, keys and intermediate files and the certificates. Okay. This is the command. We can use it like OpenSSL pkcs. uh, this is my file name. This is my file name, and it can create the key, like private key it can create it. So the password they can able to share. So by using this password, so we can create the private key. And then the immediately we have the another command like public certificate. This certificate also having the same key, same password. So it is in the format of .pem. So now we have the key and PEM, but where is the intermediate files? So how can we generate it? So that is a main task for us, like to generate the uh, intermediate files and combining all files into this in this PEM. So uh, this is using in the OpenSSL. Only these two commands we can run it, and then coming to, so once you created this PFX, once you created it into the PFX, so we need to create the intermediate files. So the intermediate files we can create by using that PFX, uh, whatever we got the PFX file, so that we can double click it. You will get this screen, and you can use the current user or local machine. It's based on your system access, like as you have the admin rights or you don't have the admin rights, so you can use the current user. So that would be the better option. And then you need to place this file into somewhere else, like how you can place it, like uh, in the personal folder. So it can have the cert manager location, so that I can show you how we can able to do that. And next we can create the intermediate files. So this certification path uh, and the root certificate, then here we can have this, this is the way. Once you saved your certificate in the personal location, right? So you can have these many certificates in that root file. So in that root file, you need to create like trust secure certificate authority and the root certificate. So intermediate certificate is like the trust secure certificate. So you have to create once that intermediate certificate, and then after root certificate. So this is the way you can create, and using the base 64x509. So as we are working on all base 64x509.cr formats, so you can browse it and you can save it in your local machine. And after that, we have the we have to combine all the, now we have .cer, trusted security authority certificate, and PEM. So how we need to combine this? By using the PowerShell. So we need to create variable. This is the variable dollar $CER equal to our location of that PEM, and the same way create another variable and the location of mm, root certificate, and this is the intermediate certificate, and this is the combining all the certificate uh, into single certificate in PEM. So get content of dollar cert, and this is the intermediate certificate, and this is a root certificate into into the actual certificate. So this is the way we can combine it. So till now we can see one small demo, like how we can able to do that, uh, the certification conversion. I can show you, like, okay, I have open SSL. I have the certificate, only one certificate I can do that as of now. This is my certificate. Okay, I have made my location. I'll change this. I can run this. So it's key created. PFX file we need to create. Now PFX file is created, PM created, and key created. Then we need to run this current machine. Next, where I'm placing the personal. Next, successfully imported. This is created. Now we need to double click. Actually, these are expired certificates, so that's why you can't able to see the proper format. But this is the way only we can able to do as of now. So this is the certificate path you have. You need to create certificate, view certificate, copy the file, and the next use the base64, and the next file name. This is certificate. Okay, internet certificate, right? Okay, finish. Okay, next we need to create one more root certificate. Certificate details, copy file. Next, this is the next. This is the root certificate, and finish. Now you can see all the certificates in your location. Which location we have saved? Sorry. See, certificate. Done. Uh, any confusions till now? Coming to PowerShell script. This is keys. So we need to set our file names properly. Then only you can able to concatenate. So that is you can easily find out. Now you can see our files ca.cr intermediate certificate and our pfx file and pem file. Okay, so now we need to combine by using these commands. So we need to run one by one. To concatenate. Concatenate. Now the file is concatenated. If you go and check in PEM, see, it starts with attributes and it contains the binary format and it can gives all the details. So we need to remove all these things and we need to save it. And the same we need to work it out for the key as well, because when you're generating, it can generate all the details, so that it's not required. uh, if you observe that PEM, you can see the multiple certificates. So this is the our main goal, to generate the certificate in PEM. Like initially we created PFX to PEM, so there one certificate generated, encryption format generated, and then we created root certificate and intermediate certificate, and these we combined in PEM. So This is the way to create the SSL certificate. Any doubts till now? Any confusions? Okay, I can take it positive way, like no issues. So once you generate certificate, so what we need to do? Like, so usually we have a load balancer in our platform, right? Like in runtime manager. So here you can't able to see, but the location I can show you. So how you can upload that is a easy way to upload in the environment. It's not a big deal to find out the issues. This is trial version, so right. So we have the load balancers. So normally we here the VPCs will create, so either production or non-production VPCs. Normally it's created in environment. So the one you created one is you need to find out whether this uh, PEM file or PFX file or it in non-prod or production environment. First you need to identify that thing, and then you need to go into the anypoint platform. You need to go into the load balancer. Here you can see these are the load balancer VPCs created. So here you can go like whether uh, production or non-production environment. You need to create it, click it here, and then so immediately the next screen you can able to find the public key and private key. You need to choose our PEM file and a dot key file. Okay, PEM.key file, and apply the changes and then deploy it. That's it. It's a simple way we need to upload the certificate in our environment. So after that, so you need to identify how you can check our load balancer certificate or properly deployed or not. So once you here you can see the view SAN, right? Once you click it here, so it can show what are the environments it's included. Like uh, we can't say like every project is the same and every company will use the same format. So someone will use each environment separate load balancer, or else they can use the non-prod for one load balancer, and the other the production have the one load balancer. So if non-prod have uh, uh, in single certificate, so here you can see the certificate details. So how many uh, certificates added into your environment, so that you can able to see it. So then you are good to have uh, uh, to give the update to your project team, like the certificate updation. So this is the entire load balancer updates, like creations. If any doubts, please you can raise. I can clarify this conversion and all.
Anyone have any questions? Please let us know. You can post your questions so we can take that.
Okay, thank.
No questions, Venkata. We got okay. Thanks for the presentation. Thanks, Marish. I guess no question, Venkata. So we can close this session, and I would like to thank you because you explained very well. Could you please answer my question? We have one question. Oh, Venkata, it is in chat.
Uh, so Java 17, as of now, there is no the proper details we have. So till now we are using uh, Java 8. Uh, so in Java 8 to 11, so we can easily able to convert the certificate. And the attributes, it's your dependency. So the how you can able to communicate your web server or the other system. So they can give, or else in your CSR, so they can provide all these details. So it is not we are able to create this PKCS. It's a depends on the certificate generate authorities, so they can able to find, they can able to give all these details. So we don't have all the information of this PKCS informations.
Maybe you are satisfied with your answer, Muhammad Umar. Mm, any other questions, anyone? Thanks, Pita. Thanks for joining. Thanks, Marish. Thank you, Mohammed. Umar. Maybe no question, Venkata. Yeah, thank you so much for the good explanation on this SSL thing. Thank you so much for the presentation.
Thank you.
Thank
Thanks
you.
everyone. Thanks giving for this opportunity, Vandana.
Yeah, no worries. We'll do more. Thank you. Thank you all. Yeah. So we can leave this call now. Thank you.
Bye.